you guys want to get a head start and maybe start writing some fun facts about yourself in the chat below, go ahead. Awesome. I'm seeing more people join the call. In case you didn't hear earlier, we're going to start in probably around 4 to 5 minutes just to give more people a chance to join. We're really excited to meet you all today. So yeah, just hang tight. Okay, it's 2:04. For the sake of time, I think it's good to just, get started and people could join the Zoom call if they're interested and they could just follow along. So welcome to Introduction to C++. As you can see, we're here with the NYU Robotics Design Team. We're NYU's official robotics team, and we compete yearly in the NASA Lunabotics rover competition. To go into more specific introductions, my name is Elizabeth. I'm a third-year design and media student at NYU Tandon. I have a lot of background experience in code and mechanical engineering, so I'm kind of just, like a jack of all trades pretty much. And I'm really excited to, be able to teach you guys about C++. Melanie, if you want to go next.
Hello, I'm Melanie. Sorry, I almost dropped my water. I am a freshman at NYU Tandon. My major is electrical and computer engineering. I just joined the robotics team. I am in the electrical sub team for the team group. Yeah. And hi.
Awesome. Sarah, do you want to go next?
Sure. So I'm Sarah. I'm also on the NYU robotics team. I'm a freshman at NYU Tandon studying computer science, and I'm super excited to teach you guys something about C++.
Awesome. If any of the participants today want to, throw an introduction in the chat, I'd love to hear it. I'm kind of wondering what background experience you guys have in code. Is this your first time coding in general, or do you have experience from a prior language? Because all of that kind of determines how quickly you pick up C++ and kind of the pace that this workshop is going to take. So it'd be great if you could just have like a general overview of what background in computer science you guys are coming from, and maybe even telling us what you plan on doing during the hackathon this weekend. I'll just give you guys a minute for that if anybody wants to.
Don't be shy. Ooh.
Treasure hacks. I plan to code. I mean, yeah, I would hope so at a hackathon, especially a virtual one. Unfortunately, there's not too many actual, prototyping you could do outside of code.
The chat seems a bit quiet today.
That's okay. That's okay. Really eager to get to the C++ itself. I see. Okay.
We'll be having like some interaction questions later on, so please be awake, Oh, no, that's Sarah. I was about to say, oh, someone responded. No, that's Sarah.
Okay,
Almost.
so kind of just close enough. A brief overview of kind of what we're going to cover today is that we're going to tell you a little bit about C++ and its history. We're going to teach you about what makes C++ different from other languages, particularly languages like Python, which I know is a great beginner language for people to learn, why you should learn C++, and kind of just going over C++ syntax, including variables, vectors, loops, file input, output, and structures. There might be some bonus material depending how quickly we get through it. So yeah. So what is C++? Well, C++ is considered to be an object-oriented programming language. It's considered to be a middle-level language because it has attributes from both high-level and low-level languages. So what that really means is that C++ has a lot of benefits, such as being able to compile itself quickly, such as low-level languages, but it also has the advantage of being able to handle complex GUIs and complex libraries. It was developed back by Bjarne Stroustrup. Apologies for butchering his name, but he developed it back in 1979 at Bell Labs to be an extension of the programming language C, hence why it's called C++. And since then, C++ has continued to develop and improve over the years. They release updates regularly still, with the next one being C++ version 23 next year. So yeah, C++ is an ever-changing language, and that makes it very popular among a bunch of tech companies. It's currently ranked the 6th most popular programming language, and it's mostly used in game development and developing complex business apps. Compared to a language such as Python or even block coding, the syntax can be pretty complex. So that could be one potential drawback, as there is a kind of a high learning curve if you don't have a prior programming experience. But a lot of tech companies such as Microsoft, NASA, and Facebook use it, so it's really good to learn. And so what makes C++ different from other languages? Well, it's pillars of object-oriented programming. So basically, we're just going to touch upon this stuff today, just so you guys are aware of what all of this is. We won't go too into detail about it, but object-oriented programming languages have a thing called encapsulation, which lets you combine data and functions into a single unit called a class. And it also lets you hide certain information from the user, which is called data hiding. So basically, you get to determine who has access to certain bits of information, which is really useful when you're building an app because, as the user, you shouldn't just have access to anything a developer might have. Same with inheritance. Basically, one object can inherit all the properties and behaviors of its parent object. So for example, if you have a class vehicle and you have its methods fuel amount, capacity, and apply brakes, you could make different class objects like a bus, a car, and a truck. You guys all know all three of these are vehicles and all of them have brakes, fuel, and all of that stuff. So these class objects will have the same attributes as the class vehicle. And finally, we're going to go into polymorphism, which it basically means that a singular entity, such as like a function or object, can behave differently in different scenarios. So for example, like the plus operator in C++, typically it's meant to add numbers, but if you wanted to, you could override the function to perform differently in a different scenario. So just to show you guys that we have like a shape draw object, right? So an object is a shape. It has the function to draw. But if you specify that it's a triangle, it'll draw itself differently from a rectangle or a circle. So those are just some of the basic principles of C++ that really makes it stand out as a programming language. That includes static and dynamic typing because C++ is a static programming language. Basically means that it determines data types explicitly upon a variable creation. So those of you who have a background in Python, you'll know that it's different because in Python, you don't have to specify a variable before you use it. That's not the case in C++. You have to be able to tell your computer what exactly you're declaring before you declare it itself, which we're going to go into right now. And some basic fundamentals in C++. Every program needs to have a function called a main. Blocks of code are usually separated using curly brackets. All statements must end with a semicolon. Every function must state what type it returns, whether it be an int or any other type that we're going to go into. And the main must return an integer. The value 0 means that it's successful completion. And if a function returns anything, it must have a return statement. Oh, and I know there's a lot of information we're throwing at you, so feel free to ask any questions in the chat at any time, or even feel free to unmute yourself. So the main function is super important in C++. We're going to kind of break down the syntax of it. So many of you guys are probably familiar with REPL or Replit, however you pronounce it. It's an online IDE. So that's what we're mostly going to be using to demonstrate code to you guys today. But if you've used it prior, you know that when you load up a file, this is kind of the syntax that appears. This is called your main function. And basically, whenever you load up C++, you have to have hashtag include iOS stream. This is your header file for your inputs and outputs. And using this line, using namespace std allows for objects and variables to be imported from the standard library. And here within your int main function, you can, as I said, you see int main and with the integer return type. And just a sample line of code, cout hello world prints hello world out to your console, and it returns 0 at the end. So yeah, that's just what a pretty basic function in C++ could look like, but it's important that you guys get familiarized with it because if you're missing your iOS stream or even your namespace std, your code won't perform properly. And some useful libraries to keep in mind would be the string library. So anytime you want to use strings in C++, you have to include hashtag include string, or else your code won't compile. Same with vectors, you need to import the vector library and fstream to access input and output files. And so again, I'm not sure the background that you guys have in code, but a brief overview of variables and types in C++. We have integers, which are numbers stored in ints. The syntax for int, here you see in blue, that's kind of where we're declaring what type of variable it's going to be. So here we're declaring that it's going to be an int, followed by the variable name, and then its value. So for example, int x is equal to 5 would be something that would work. Then we have floats, which are similar to ints, except they're meant to store decimal point values. Then we have Booleans, which either hold a true or false value, either a 1 or 0. So again, you have to declare that it's a bool, give it a name, and then set a value that it's equal to. And then we have chars, which hold individual letters, individual characters. So again, you have char, var name is equal to whatever you want to put inside single quotation marks. And then you have strings. So strings are basically a bunch of series of characters, string together. To use strings, you have to import the string library, and the syntax for declaring a string is string var name is equal to whatever you want to put in quotations. So while chars use single quotes, strings use double quotes. And just to let you guys see what that would look like in code, instructors, can you tell me, is my screen still sharing, or are you guys only seeing the presentation? Oh, you guys could see the replit? Okay, awesome. So here you could see we have, we're just declaring a bunch of variables. We have a char, A123 is equal to A. And using our cout statement, we could print that out here. Here we're declaring a float. But as you could see, we didn't give the float a value yet. And we're going to get an interesting output when we actually set it out. Here we have our float pi, which is equal to 3.14. Our bool 1, which we're going to set equal to false. And here you could see that you could actually declare multiple integers at once. If you do int the name, and then a comma, and then another name, and then a comma, another name, you'll declare 3 ints all in one line. So that could be useful if you're dealing with a bunch of variables and you want to be able to keep track of them better. And you'll see that when I run this code, it'll output anything that we set our variable equal to. Something interesting to keep in mind, float b, it actually printed out some funny looking junk because we didn't actually assign it a value. So what C++ does is that it gives it a garbage value, a temporary value until you actually store something within it. So that's just something interesting to note, that make sure you assign your variables actual numbers, or else you're going to be working with garbage numbers. And going back to what we mentioned earlier, after variables, we have user input. So again, typically what is like a print function in Python is known as cout in C++. So cout is an object of the class OStream. And it's used to just display an output. So for example, you would have cout hello world. You make sure you include these little greater than signs, or no, these are less than signs, right? And then at the end, you could include endl, which basically means that the next time you want to use cout, it'll continue off a fresh line instead of, just printing one long chunk of text. And then we have cin, which does the opposite of cout. Cin lets you actually accept input from the keyboard itself. So if you run your code, you could actually type out what you want the console to accept. So here, for example, you could see that we declare string s. And then what do we want s to be equal to? Well, that's whatever the user wants to type in. So we have cin greater than s. And just to show you guys what that would look like in code, again, you're declaring a variable type. And then your input, however, would come from the cin function. You would type out your response in the output console. And what would be printed out would be whatever gets stored into that variable. So that brings us to our first exercise. Kind of fill in the blanks. We want to, so fill in the missing parts to print the sum of two numbers that have to be put in by the user. So you see we have these blank lines here, and we're trying to add x and y based on user input. So what do you guys think the syntax would be to do so? What would go inside the blank spots? I'll give you guys a minute to figure it out. If nobody knows, I'll explain it, but I kind of want to test you guys to see how well you're picking it up. Brian, yeah, exactly. So pretty much just what you have to do is just have cin accept the value for x, and then cin again accept the value for y. And then from there, you'll be able to get the sum of whatever you're trying to add. And now I'll hand it off to Melanie to explain more about arrays.
Okay, so an array is basically a collection of similar data which you could store into one variable, which then you could later call upon using the placement of where it's located. An array is basically a static, and it's not dynamic, meaning that it cannot change the placement of any of the, as it's running the code, it does not change, right? So here for to declare an array, what we first need to do is define the variable type, which here in this example is string. Then the next thing you do is define and name the array, and here it's car. Then you would use the square brackets right after you name your array, and then you would write the elements of how many elements there are in the array. And basically, if you open the array syntax. Okay, if you can look at our code here, in the first step, int array1, we have 10, meaning that there will be 10 elements in this array. In the second one, we could also use a variable we could input a variable, but the variable has to be an int where we could basically substitute the number in to the array, right? I hope I said that right. And so, okay, basically, if there is no element number inside the square brackets and you have your input, you declare the numbers or whatever the values in the array, it will automatically have the size of the array. But again, you have to start declaring what will be in the array. Could we go back to the other slide? Okay, continue. So holding a string in an array, we need to first start with string, then the variable name, then how many we're holding, and then we put an equal sign to assign the variables for each letter, right? So here in the string, the syntax for this is that we open with a curly braces, and each string will hold a double quote, right? And then they're each separated by a comma. And of course, it ends with a semicolon. For an integer, you would do about the same thing, except because they're ints, you don't need the quotation marks. And of course, you would put int instead of string. So next, let's do our array exercise. So could someone tell me if there's an error, because here there's some errors and there's some of them that are correct. Could you tell me what is wrong with the first one, or is it correct? Right now we're testing syntax of creating the array. So is the first one correct or is the first one wrong? Someone type in the chat. Anyone else? Anyone else want to participate besides Brian in these things? Yeah, we're talking about like string fun 8 right now. So the first one is actually wrong because if you use because if you see right here, string is capitalized, the S is capitalized. See, it's very finicky, the syntax. It's very like complex in C++, so it's very case sensitive. So if you use a string, if you use a capital S for string, then it will cause a syntax error. So that is actually incorrect, and it has to be S lowercase to make it an actual string to work. So next one. So the next one, I guess you could say what Brian says. It's wrong, yes, because an int and we're putting in a string values. So of course it doesn't work. So okay, the third one. Okay, any answers on the third one? Where int my num 3 curly braces 1 3 10. Yes, it is correct. That is correct syntax. And the next one? Yep, that one is also correct. It has proper syntax with the correct the correct the correct type matching the variables that is inputted into the array. So and then we have the last one, which is my int my array 4. Is that one correct or wrong, and why? Yes, it's wrong. It has the same problems as the second one. Because even though like they are numbers, because they are in string, they're string values despite being numbers inside the string. They're still counted as strings. So let's go on.
Oh, and I just want to reiterate the one point Melanie made again, just to drive home how finicky C++ can be. So the first one, it could have been correct had the S in string just not been capitalized, but C++ is case sensitive. So you always have to make sure you're paying attention to the little details, because if not, you'll think there's an error with your logic, when in reality, it's just with your syntax itself. So it's always important to keep in mind.
Okay, next we have vectors. The difference between vectors and array is that vectors can resize itself and they are dynamic. So here the proper syntax for vectors would be vector caret object type and caret env1, right? And so there's a lot of imports from like a vector library that you can use. So next one. So here we have like assign, which assigns a new value to the vector elements by replacing the old one. We have pushback. The pushbacks the elements into a vector from the back. We have pop back. It uses to pop or remove elements from a vector from the back. We have insert, which inserts a new element before the new element at the specified position. We have erase, which removes an element from the specific position. And then we have the next slide. Yeah. Okay. We have swap, which swaps the contents of one vector from another, and size may differ. We have clear, which removes all the elements of the vector. We have in place, which extends the container by inserting new elements at position, and place back, which inserts a new element into the vector container. The new element is then added to the end of the vector. So yeah. Oh.
I could explain this part a little bit, Melanie. So as she stated, difference between vectors and arrays, the reason that vectors have all these modifiers is because once you declare an array, believe that you can actually continue adding elements to it. So if you said your array is going to be of a size 10, I don't believe you could change that once it's already set. But the benefit of vectors is that because they're so dynamic, you're able to add so many other elements to them, switch them around. So here we have us declaring a vector of ints named v. You see, we didn't declare a size for it yet. And again, keep in mind, you have to import the vector library. Here we're filling our vector with using the assign function with the number 10 5 times. So here we have the length of our array versus what element it should be filled with. And we're going to loop in a little bit, but basically, essentially what we're doing is that vectors are really easy to do in C++, right? So here we're looping through the size of the vector and just being able to print out all of its values. And again, here's where the benefit of vectors actually come in. Vectors have a pushback function, something that arrays don't. So vectors, again, you're able to change their size and add elements to them, which is why they're so good to loop through. And pop back, which lets you remove the last element. Insert, which lets you just add an element into any place within the vector itself. So there's a lot of creative freedom that you have with vectors that you don't necessarily get with arrays. And when we run this code, yeah, again, you're able to just kind of see how much information you're able to extract out of your vectors. The first elements after looping through them and switching the values, erasing values, swapping vectors even, vectors are a pretty big topic on their own. So we really recommend kind of just looking more into them because there's even more modifiers and functions that we didn't mention. But here we just have the basic ones.
Okay. So next, as was mentioned, we have loops, right? There's two different types of loops. We have for loops and while loops. So here for a for loop, we have loops are basically where you could, instead of like going through each like step manually, it like automatically does it for like if you have a long numbers to go through and you're doing the same step for like each. So here we have for loop, right? We have like to fill out 3 parameters, conditions, 3 things, right? So first part of it is the start, basically is what the number is, the beginning of the loop, where is it starting it? So basically you would assign a type, right, int to a variable which value will equal to 0 in this case, right? In this case, we'll do numbers counting 0 to 4 because here it's starting at 0, right? And here is the condition. The middle is always the condition, and they're always separated by semicolons, right? So the condition is saying that I has to be less than 5, meaning that the loop will stop once this condition is no longer true. Here, as the starting value, 0 is less than 5, so it will continue to loop until, and here the step is that every time it finishes a loop, it will increment 1 value to the initial variable, right, I. So once it goes through the first loop, it will become a 1. Once it finishes, whatever is inside the loop, it will increment 1. So that is what the I++ stands for. It is adding 1 to the variable I, right? And so here we have what's happening inside the loop, what each loop is going to do, where we have it prints out the value of I, and then it creates a new line, right? So here we have the first value of the loop, the first loop would create 0. Once it finishes, I becomes 1. Then it checks to see if 1 is less than 5. It is, so it continues on to print this so that it would, and then it would continue that way. And so it's a question, would it still work if it was? No, it wouldn't, right? It wouldn't work because that's part of the syntax. Right? Yeah. It was back me up on that. That's true, right?
I believe that is true.
Like that would be wrong syntax. Like it wouldn't work.
We could just double check that really quickly. But I don't think that it would work simply because you need to have those little brackets there. So let's just hear where we're typing out our elements instead of that. So Matthew, you essentially said, oops.
Basically concatenating.
Yeah, because I believe you can't just add it like that. I don't think it would work. Yeah, so you see right here, our vector elements aren't printing out properly. So no, it just wouldn't be possible. But that is a good question.
Okay, so here we have the instead of like having the initializer is inside the loop, and then you would have to, you know, like put the incrementation inside the loop. I mean, outside the loop is the starter. Oh, wow. So basically it's doing the same thing, but because there is no start or step inside for a while loop, it just goes through the condition. So as soon as the condition is false, it breaks the while loop and doesn't really, it goes over and then it checks, but then it doesn't work. It just continues, right? It continues hours after. Yeah. So do a while loop is also a variation of this where it executes the code, then so here we have another exercise for everyone, right? So you're based on what on using a for loop or while loop. I mean, I think you should try using both, right? To printing out a loop that that counts numbers 0 to 10, just like that was demonstrated in the for loop and while loop side. For a little extra challenge, you could try printing out all just the even numbers from 0 to 10. So we'll give you 5 minutes.
I think 5 minutes should be good. So yeah, just try 10. You could for a while, you know, that's something that a lot of people don't exactly use prior to using C++. If you guys want to go back to the previous slide, just let me know. Yeah, Matthew. I mean, honestly, that's kind of, you know, how you would do it when it comes to a for loop. That's pretty much the conditional that you would put it in. No, that's okay. Your answer is still correct. Yeah, we'll give anybody else just a couple of minutes if they maybe want to try the while loop or wants to try the even numbers in specific. That wasn't something we covered, but if you have prior programming knowledge, you might know a way to do that. So yeah, we'll just give you guys another 2-ish minutes. Oh, Sarah brought up a good point in the chat, Matthew, just referring back to your previous question. So the reason that didn't work was because you were gonna add an int with a string. And if you add two strings together in a cout statement, then that would be able to work better. So yeah, Sarah, thank you for bringing that up. Okay, awesome. We're gonna give you guys another maybe minute. And if not, we could start moving on to the next part of the lesson. Um, yeah, I mean, the idea of looping through 1 to 10 seems pretty rudimentary if you have a background in computer science, but it's just the idea to kind of get you guys familiarized because if you come from a language like Java, however, you might be able to, transfer that over a lot easier. Okay, awesome. So we're gonna go to the next part. Here's an answer using while loop. Melanie, if you want to go over these.
So basically, like the examples, you would first create your variable for the while loop, right? Then you would create the condition of I being less than 10, right? And so, wait a minute. I feel like I forgot to mention something, but I don't know. It's like on the tip of my tongue. Wait, about like the conditions. Anyhow, right? So then you would write what it would do once you're going through each step, each incrementation of the variable you put in your condition, right, until it proves false, right? The same thing for the for loop, but you know, the initialization of the variable I would be inside, as well as the step, the incrementation, you have the I plus plus, right? And as well as what is being done.
Oh, Matthew, you're right. I think while typing this out, I forgot to include an equal sign because it would print out
That's
one
what
through
it
nine.
is.
Yes,
I
rather than.
knew something was wrong. I was like,
Thank you for pointing that out.
of course, and yeah,
Oh,
for
for
the
the
step,
challenge problem.
yeah, just up for the challenge problem, you just change the how much it's being incremented in the step portion, right? For the for loop, and then here's just inside the while loop, right? Thank you, thank you. Okay, so next we'll pass it off. What's this?
Oh,
Okay,
okay.
sorry about that.
So this isn't just really quick. This wasn't something that we mentioned prior, but I wanted to kind of see again, gauge how much background computer science knowledge you guys have. And so basically, what can we add to this blank space to make our function stop when I reaches 5? So you see our loop is meant to go all the way up to 10. But if we wanted to somehow pause this loop at the value 5, kind of, do you guys have any idea maybe what we could have inside of it to make sure that happens? We'll give you guys like a minute because we know we didn't mention it prior, but this is good knowledge to have for when you're working with for loops because it helps you be able to, well, you'll see. Okay, so I might as well say it. Basically, C++, you have two additional functions that you could use within a for loop. The one we would use here is called the break function. So basically what it does is that once a certain condition is met, in this example, it being when I is equal to 5, your for loop will completely stop regardless of what you told it to do in its initial for loop. So here our function would break, and that means that rather than looping through 0 to 9, it would only loop up to the number 4. So that's, break is what lets you completely stop a for loop. Meanwhile, continue just lets you continue on with whatever is going on in the loop. So those are just two good additional pieces of information to have when working with for loops or even while loops. Oh, actually, especially with the while loops, because it lets you actually break that initial condition. And if not, you might have an endless while loop, which is never good. And now we could pass it off to Sarah just to talk a little bit about file input and output. This isn't a super important topic in C++ necessarily, but if you ever take a future object-oriented programming course, this will be what they cover in the beginning. So it's just good to establish what it is.
Alrighty, so this is a little bit of an overview of file input and output. So we're just going to go over this. So to read a file, we need a stream object to get input from the file. And then we need to make sure that the file has opened has opened successfully. And then we need to go back and read and loop through the file, then reset the position to the beginning of the file. And then we have to set flags inside the stream object to prevent you from reading the file. So you clear them. And then you can close your file. So this isn't a super important topic. This is just a little bit of an overview to kind of give you an idea of like what something like this would look like.
Yeah, kind of just to cap off with that, basically, C++ gives you the option to actually edit files directly. So if you have a text file that you import within it, you could change the content that's written inside of it, or even produce your own text files within C++. It can be a little bit finicky to work with because you have to look through individual lines within your data file. But it's something really useful to look into if you could see yourself maybe manipulating text of data with C++.
Now, I'm going to go over a new type of data structure called, a struct. So usually when you have like an int or a string, you could represent something like a name or an age, which like could be represented by some like just a number or just a word. But sometimes if you have something like, let's say a person, you might want to give it multiple attributes. So I'll kind of explain that a little more. So this is kind of just a little bit of like, this is the structure of a struct to kind of give you an idea of what something like this would look like. So if you see here, right after, so we identify the type, so that's struct in pink, and then you get to name your struct. And then within the curly brackets, you can kind of give it attributes. So that could be an int or a string or a Boolean. And then at the end, you can actually make instances of that object type straight away. So to give you an example, like I said, for the person, you might want to give it multiple different attributes. So a person can have a name. So as you see at the top, we've named our struct person. And then within the curly brackets, we have a string called name, and then an integer called age. So this person object not only has a string, but it also has an int. And then at the bottom, we have person1, which is an object of the. And if you look at main method, you can see that you can usually call the object you made that was person one, use the dot operator, and then the attribute name, which is name. And you can set it equal to another string since name was given the string type in the struct. And then you could do the same thing with the age and give it a new integer value. So now if we print our person's name and then we print our person's age, it will show happy and 5.
Exactly. So kind of just again, this is something very important within C++ structure when we kind of start breaching the whole topic of object-oriented programming. So, just to emphasize what Sarah was saying, we're declaring a struct named person. We're giving it attributes such as a name and age. And within our main function, after we declare it, we're actually able to modify and modify its attributes based off of whatever we declared within the struct. And I just wanted to tie this into that topic of encapsulation that I mentioned earlier, because here all of these attributes are able to be accessed within the main function. But in the future, you're actually able to specify to maybe private data so that not everybody is able to access it unless you want them to. So again, that's something to continue C++ with, but structs are a great way to get introduced to object-oriented like handling.
All right, so we have 3 examples here of different syntax. Look these over and see if you guys see any errors. You guys can type in the chat if you see an error in one of them. If nobody sees an error, that's all right too.
Do you want me to go on to the next slide?
Yes.
Oh, Matthew said B. Interesting guess. Okay, we'll see how we'll see which ones are incorrect. Sarah, just let me know when you want me to go to the next one.
You could go to the next slide. There are actually no errors in any of these. So syntax is pretty rigid, but if you see like you can actually create your person object within your main method. You don't have to do it at the end of your struct.
Yeah, so all of these are actually correct. Here's just an example of the different ways you could initialize a struct object.
All right, so now we have an example problem. So now create your own book class with the members name, number of pages, author, and whether or not the book is buyable. So we have 3 example books with titles, page numbers, authors, and whether or not you can buy it. If you guys want, you guys can try this out on your own, or if you want, you could type in the chat, like kind of how you do this.
Yeah, we'll give them around 10 minutes. Around 10 minutes to kind of try to figure this part out. If you're not familiar with structs, you're aware it could be a little daunting, but just try to initialize a book class and just give it some attributes. Keep in mind everything that we kind of learned earlier between user input, variable loops, and kind of see what's the way you think you this. If you go back to the previous slide, or if you have any questions while working on it, please let us know. So yeah, we'll give you guys actually around 8 to 10 minutes because we're running a little bit short on time and there's 1 or 2 more topics we want to cover before we end.
if anyone needs to question on anything, also feel free to leave your questions in the chat.
Yeah, we'll give you guys like another 5 minutes, just for the sake of time. Um, but we are aware this might be a little challenging, so it's okay if you're kind of struggling with it or aren't exactly sure where to kind of start. Okay, for the sake of time, I think it'll be pretty good if we start going into the actual answer itself. So I'm really interested to know how far you guys got along with it. But again, we might as well just, explain kind of the step-by-step process of it. So Sarah, I'm gonna go to the next slide and you could just explain kind of what's going on within the code.
All right. So this is our book struct. We've created the members for name, author, pages, and whether or not it's buyable with 2 strings, an int, and a boolean. And then at the very end, you can see our library with the square brackets 3 to initialize um, an a book object array with 3 places. And then if you see in our main method, we changed the name, pages, author, and Boolean for whether or not it's buyable with our first book object within the library or object array or book array. You can also, so this is what we did to sort of add the parameters for our other two books. So we did the same thing for the second and third book object within the library book array. And we initialized those with the corresponding values. And then if you see in our for loop at the end, so that will shuffle through when I is 0, 1, and 2. So the places of all three of our books in the library array, and it will print the name, number of pages, author, and Boolean for whether or not it's Bible in that order for each book, one book at a time.
Awesome. Yeah, that's exactly it. So that's kind of just the code that you would use to, like we said, declare these book objects and assign them values. And so that leads us into our next topic. Sarah, if you want to go over these as well.
So the nice thing about, so I'm going to introduce classes to you guys. So classes are, they're pretty similar to structs. However, one nice thing that I think Elizabeth briefly mentioned about structs is that all of their members are initially public, so you can kind of call them immediately. The nice thing about classes in a different way is that they're private to begin with. So I'll explain that a little bit later. But classes, basically, they have attributes or members, just like structs do. So these would be things that whatever your class name, so that could be, for the example book, the book struct, they have a, so let's say if this was a person, they would have a name, or they'd have a hobby, or an age. But then with classes, you can also add behaviors. So these are the things that whatever your object name can do. So in the example of a person can have a birthday, and that will do something to the age. Or they could change their name, and then that would take in a new name and do something to the name. And then, like I mentioned, these behaviors and attributes, or variables or methods, or members, you could call attributes members, are private by default. So you will also need to add in public into your class, which I'll show in the example, to make sure that you can use, you can call these attributes or members from your main method. And the same thing for the behaviors. So here's our example for classes. We're going to kind of go through this a little quickly. But so like I mentioned, maybe you want to have a person class, and you not only want to give them attributes, but you want to have it so they can do things. So our person class has that public statement in the front to make sure that we can use these attributes and methods later in our main method. Then we initialize the name and hobby strings, or string variables. And then we do the same thing for age. And then we add in some methods. So we add in the have a birthday and the change name methods. So if you see with the methods, we start off with the word void. So that's our return type. We don't have to worry too much about that, but it's kind of just the type of variable that you'll be returning. And in this case, nothing is actually being returned. So we have void. You don't have to worry too much about that. But then if you see in our main method, you can see that just like our structs, we can initialize a person object. In this case, that's Abigail. Abigail's name is set to Abigail, and her age is set to 17. And then different from our structs with classes, we can use have a birthday to, if you look into our class, it has the statement age plus plus. So that will increment our age by 1 or add 1 to our age. So 17 becomes 18. And then we can change Abigail's name to Abby. You don't actually have to put string in there. That's a typo. It should just be in quotes Abby. But that changes her name from Abigail to Abby. And you can also notice that when you have a method in a class, it's kind of a side note, but you don't have to call, like you don't have to have a person parameter within the parentheses because it's within the person class. So it already has access to all of those variables and also itself. That's just a side note because we didn't really go over functions, but something nice about classes.
I kind of just to like add on to what Sarah said about classes, they are pretty similar to structs in a lot of the ways that you could access information. However, classes are really the stepping stone into kind of getting introduced to object-oriented programming like C++. With classes, that brings us to those 3 pillars of C++ that we mentioned earlier, inheritance, polymorphism, and encapsulation. Because once you start declaring more class objects, they could start being related to each other. So for example, you have a class person, and then when you want to establish a class, let's just say, I don't know, brother or sister. Those are 2 classes that are potentially related. And the ways that you could get that data to actually reflect off of each other is through stuff such as polymorphism and determining who can access what information. This person, if we gave them something like a bank account, we don't want anybody to just be able to switch their bank information. So you would make that information private. You see here already everything that we've established is public, but that is more complex C++ topics that we won't exactly have time to get into today, but they're just good to keep in mind if you want to keep learning about it. So yeah, we are running a little short on time. So that's kind of the majority of all the information we're going to cover today. If anybody has any extra questions, feel free to leave them in the chat or even reach out on the Discord. I'm in there, and a bunch of other mentors from the NYU robotics team are also there. So if you have any questions related to anything technical, wanting to learn more about C++ or anything college based, feel free to reach out. I want to say thank you to our other instructors who are here today for helping us put this all together. And thank you to all of you guys for wanting to learn more about C++. And thank you to Treasure Hacks for hosting this hackathon. I wish you guys the best of luck this weekend. I'm excited to see how your projects turn out. Mentors, other instructors, you guys have anything you want to add or?
No, not really. But we do have a mentor help channel in the Discord. If you want to find any of our Discord names, we'll be in there. We all said that we're part of NYU Robotics, so you'll be able to find us pretty easily.
Yeah, absolutely. And remember, even if it's something a bit more like, questions about college, robotics, anything, feel totally free to reach out. It was really great to get to see you guys all today. I'm going to end the workshop around here to let you guys get back to working on your projects. So yeah, thank you, everybody. So instructors, we could, just leave the Zoom call now. I'm sure they have other workshops following this one. So bye, everybody.